It's about that time in the basement. UPS battery replacement and maintenance time. I would love to say I schedule that and do it responsibly, but really I just kind of wait till there's a power flicker and one of the UPSs complains. I got quite a few back there on the bottom of that shelf, all like 3000 VA, some 240 volts, some 120 volt, and that's running all the equipment over there, and some equipment over there. Anyway, point is, I've got all those UPSs. I've got a couple more UPSs running all my video equipment down here. Others for desktops and UPSs all over my house. I got tons of them. By tons, I mean maybe like 20 UPSs, 25 that are operating right now, and probably another 15 that are just sitting there not doing anything because they're, well, not working or need batteries. Anyway, point being, I had a power flicker the other day. One of my UPSs died. The UPS didn't die. The batteries were completely kaput. Replaced those. That was in an APC Certa 3000 XL, I think is the model. 16 individual batteries in 2 large battery packs. I did a video about that like a million years ago about replacing the batteries in those battery packs. Link in the description. Today, though, we're talking about this guy. I would lift it up and show it to you as usual, but it's still got the batteries in it and it's quite heavy. But it is this, the Emerson Liebert GTX4, 3000 volt amps, 120 volts, and it has a NEMA L530P plug. Well, the P means plugs, that's kind of redundant. And on the back here, as you can see, well, okay, first of all, let's acknowledge the dust. It's very dusty. It's even dustier in the front, but you couldn't really see too much of the dust in that last shot. But yeah, look how much dust is just caked around these receptacles and whatnot. But anyway, it's got an L530R on this little pigtail, because I guess they just couldn't fit the entire receptacle on the back of the unit. This is the power inlet cable up here, and we have 6 120 volt standard NEMA receptacles here, 15 amp receptacles. Some of these 20 amps. No, I'm sorry, they're all 20 amps. I'm looking at this on the monitor because obviously this is facing away from me, and both between the lighting and the dust that's caked in there, they look like 15 amp receptacles, but of course they are right there labeled 20 amps. And these are, in my experience, very good UPSs. I bought these probably about almost 10 years ago. In fact, 9 years ago on my Extras channel, I did a video walking through the menu system on these UPSs. Don't know why I did that, but it's there because, you know, in case anyone's curious. And they held up like workhorses since then. But maybe about 6 months ago, maybe even more than that, the batteries, I have 2 of these identical units, and the batteries on both of them went kaput around the same time. And I was like, I got to order replacements. Replacement batteries are very expensive for large UPSs like this. The individual batteries, not so expensive. It's just they take a bunch of them. Like for those APCs back there, I think replacement batteries from Refurb UPS, a company that, well, refurbishes and sells UPSs and batteries, they have good batteries and they have good used stock. I buy from them all the time. I recommend them, not sponsored, blah, blah. They happen to be relatively close to where I live, so it's like next day shipping for regular ground prices. That's another advantage for it. Anyway, good company, Refurb UPS. Again, not sponsored, just I've been using them for years. Not where I got this UPS, but it's probably where I got the batteries in this UPS. Point being, from them, I think shipped the batteries for the APCs cost about $400 a pop. I have 6 of those back there. So, and the batteries need to be replaced every 3 years or so. You can see how that adds up real quick. I think these Lieberts take 6 batteries. Well, it's been a while. We'll take a look. We'll open this up. That's the whole point of this video, is to not only replace the batteries, but also clean out all the dust, not just the front and back panels. I actually want to open this thing up, get it really nice and clean on the inside. Also, check capacitors and stuff, because I'm not a UPS expert. I just own a lot of them and have owned a lot of them. Had a lot of them fail for various reasons. I haven't gone crazy diagnosing all their failures, especially for the cheaper, lower-end UPSs. But in my experience, especially with these heavier duty, more commercial grade, like enterprisey, medium business UPSs, they tend to be extremely reliable as far as getting power through them, because obviously they're uninterruptible power supplies, and the manufacturers should and presumably do prioritize that uninterruptible aspect. So even if the batteries go bad, even if some other circuitry relating to the batteries go bad, it'll still flow power through to your equipment. So in my experience, the number one thing that goes bad with these UPSs is the charge circuitry. That is the power supply that actually is responsible for the batteries being topped off when they're not being used, when the UPS is just sitting there idle. And that's a huge problem, because when the charge circuitry dies in UPS, again, in my experience, it usually doesn't set off an alarm on the UPS. Maybe on a self-test cycle, it'll catch that the batteries are low, but it won't really express to you why. And so you might just think, why are the batteries, constantly needing to be topped up? It must be bad batteries. Inevitably, you go out, you buy some replacement batteries, you stick them in the UPS. Everything's fine for a while because, of course, the batteries are usually shipped with a decent charge, and the UPS is detecting the proper voltage on the battery array. Well, a battery is an array. It's by definition, but everyone calls cells batteries. So let's just call it the array of batteries in the UPS, giving the correct voltage. The UPS is happy. Not a problem. Doesn't even try to charge those fresh batteries. Then eventually, of course, the voltage will float down, or you'll have a power outage. The batteries will get consumed and won't get recharged. And so now you've replaced what were probably decent, or at least, usable batteries with brand new batteries at your own expense. And now those new batteries, if that whole process takes a while and you don't catch it, that the battery voltage is drifted down and down and down, and you have reliable power, so it doesn't really need to go onto battery that often, and maybe you don't have self-test enabled on the UPS, it could very well be those new batteries. The voltage just floats down until the batteries go well below their safe minimum, and the batteries are basically kaput. They can never be recharged back to their full capacity, if at all. And so now you've wasted basically 2 sets of batteries, and on a very large UPS, or none of these UPSs are very large. I mean, very large are the ones that, are mounted alongside a wall in a data center that take up numerous cabinets, but very large in the context of a basement, a home lab, whatever. These large UPSs, you don't want to go through 2 sets of batteries just to find out that the UPS charge circuitry is actually faulty. And if I sound salty about this, it's because this has happened to me. I've thrown good money after bad, putting batteries into a UPS that was bad, and I didn't even realize it until, well, a couple of sets of batteries in. Unfortunate, but now I'm on the lookout for that, obviously. Now, I took these UPSs offline because, like I said, I have 2 of them. I'm just going to show one here because they're perfectly identical. They're both functional. The charge circuitry seemed fine. Everything about them seemed good. But when I open this up, I want to, amongst other things, just check all the capacitors, because they're the things that are most likely just to degrade or fail over time, especially because sometimes these units can run warm. This, by the way, I should have pointed this out earlier, is a double conversion online UPS with a bypass. I shouldn't say bypass, because bypass usually means bypassing the entire UPS or the entire battery system and everything else in it, with an eco mode that essentially just bypasses the double conversion aspect of the UPS. It will still function as a UPS, but it's more like a cheap, like AVR UPS, automatic voltage regulation, that all that does is when the voltage drops below a certain point from the mains, it kicks onto battery as if the voltage had completely gone out, as if there was a blackout. Same if the voltage goes too high. Now, a double conversion online UPS means that it's always converting the line voltage to the output voltage through an intermediate voltage that's usually, well, DC and the battery voltage. So in other words, if you have, like, let's say 122 volts coming in from the mains, the UPS will output 120 volts if that's what it's set up to do. And that double conversion has a couple of advantages. For me, the main advantage was I don't have like a proper generator for my house, and occasionally we do get lengthy power outages. So I have a couple of contractor style generators. They output real messy power. Their voltage fluctuates like crazy. My old AVR UPSs, which I had a lot, just hated the generator's output. They'd constantly be kicking onto battery, kicking off the battery. And the problem is, by the time I got the generator set up, my equipment was on UPSs for a while. The batteries would already be low. And while the voltage from the generator is fluctuating around, it wouldn't charge the batteries for the most part. And it would constantly be draining the batteries. So it basically just gave a little extension to the amount of time my equipment could operate via the UPSs. It was double conversion online, much more tolerant to external mains voltage fluctuations, because it is converting that mains voltage to a DC voltage internally and then back to AC. So That's the main reason for me to get these. For me to spend a whole heck of a lot of money on double conversion online UPSs, because those will always be more expensive than, you know, the cheaper AVR style or any other technology that you mostly see on the consumer side. Disadvantage of double conversion online is that it's inefficient. You know, this, of course, it's not a zero loss conversion from AC to DC back to AC and then to the output. So that's what I was talking about earlier when I said these UPSs have a bypass facility, at least these Lieberts do, where in eco mode it will just run power basically from the mains right back to the outputs. But if power does fail, even briefly, it will cut in the battery subsystem and voltage conversion subsystem. It'll basically change it back immediately, probably via a couple of relays, to a double conversion online UPS, and it'll run off batteries that way. And it does have some hysteresis that it doesn't like constantly go from eco mode. Like if the power is a little unstable, it won't constantly go from eco mode back to double conversion back to eco mode. It's fairly smooth about that. It only reverts back to eco mode, I think, after power is stable for like, I don't know, 10 minutes or something. Anyway, enough waffling. That's why I have these UPSs. And actually, I haven't powered them on in like 6 months. So, and because these have the L530 connectors, I have L530R again, it's redundant to say receptacles. I have L530 receptacles on my wall back there behind the equipment. So those UPSs back there are properly connected. What I have here is a completely unsafe, improper cable. It's a NEMA, oh god, I'm spacing on what it's called. You know, the standard North American 15 amp plug. That's then going to this L30R, which, by the way, I did label 15 amp max because this is only a 15 amp plug. It was admittedly plugged into a 20 amp receptacle, and this is a 12 gauge wire, which should have a 20 amp ampacity, at least, especially at this length. It's pretty short. It's maybe about 5 meters. But as you can see, this plug was not too happy. I was drawing maybe 10 amps through this, maybe peaking a little higher for an extended period of time, and as I had a temporary UPS configuration set up back there, and it got all toasty inside. Weird. But it should be sufficient for testing out this UPS on the bench briefly. You know what? I'm getting all tangential here, and I apologize for that. This is going to take like 8 minutes to start up. What I do want to check, though, is this got all like carbonized in here. What kind of resistance do we have between these two pins? This should, of course, just be an open circuit right now. Okay. I just want to make sure also that it wasn't a fault in the plug that was causing it to overheat. And as you can hear from the beeping, it's very angry. It's very angry about the batteries being bad. And you can see we're on eco mode because that little leaf is illuminated green. Hooray. Ooh, and my input voltage is just about 120 volts exactly. No decimal point there, but you know what I mean. Battery 0%. The thing does at least still power up. It didn't like die as it was sitting there. And before you work on the inside of a UPS, obviously unplug it, for the love of God. You don't necessarily have to unplug it when you replace the batteries. Those are meant to be replaced while the UPS is turned on. I mean, I don't mean a battery replacement. I mean, I'm going to open up the rest of the chassis and actually poke around in here. So definitely unplug it for that. And also, if you're going to poke around in here, of course, remember, you could have line voltage at very high amperage floating around in here if the batteries are still in here. Even if the batteries aren't ostensibly good, you could run into problems. So just always disconnect the batteries and disconnect the mains before you actually poke around on the circuit boards or whatever in here. So first things first. Oh, fuck. Well, okay, I had to move. Apologies for the shaky camera right now. It's also dusty. I don't think the lens is too dusty though, but that was dumb. So the front panels of these just pull off. They like clip in with these two metal clips at either end. Much better than plastic clips, but you can see the scale of the dust problem. Now, don't let your UPSs get as dusty as mine. You know, do as I say, not as I do. I try to vacuum these out periodically. I don't know. I'm not very good with UPS maintenance, I'll be honest. It's kind of a hassle, especially when you have a lot of UPSs. I don't feel like spending every freaking weekend messing around with UPSs. That's actually worse than I thought it was going to be. Because let's face it, this fan is absolutely disgusting. And I'm sorry you had to see that. And I'll give that a much better wipe down and, well, I mean, maybe even get a new fan for it. We'll see how bad the fan is when we open it up. But yeah, I actually feel bad letting it go that long because I was still had dust there. I was basically choking this thing for air. So it was probably running hotter inside than it should. And that's one factor in how long batteries are going to last. You know, the lower the temperature you can keep the batteries, the longer they'll last generally. So to get the battery compartment cover off, 4 screws, 1 in each corner, very straightforward. And this piece of metal, quite heavy duty metal. I mean, really good quality construction on these. And you can see the battery wiring harness. And then it's probably would be easier if this wasn't right against the table, but just take the battery connector out from there. And on the battery connector, there are these 2 little pips, one on either side, and you just have to push those in and then pull them apart. They're just these locking tabs right here. Move this cable out of the way, and now the battery pack should pull out. Oh, the state of these batteries. Well, I think it's obvious with the lights reflecting off of them. These batteries are a bit, shall we say, wavy, which means they've probably got way too hot at some point. And yeah, really rather disgusting. I definitely let these go way too long. But anyway, so here's the handle that you used to pull the battery pack out, and on top of it are 2 screws. And then similarly on the back of the battery pack, two more screws in a vertical orientation there and there. And now with those screws out, the top of this should lift off. It was a little stuck because the batteries have kind of expanded in size, but you know, no matter. And then if you tilt it up on the back, the reason for tilting it is because the 2 battery wires are actually over this tab, so you can't lift this end straight up. You got to pivot it from the back and then sort of wiggle it and get it clear of those cables, and then it comes out. Looks like we're impinging upon this wire a little bit. Doesn't look like the insulation was actually too damaged, or at least not damaged down to the copper. And so for now, let me get the UPS out of the way. We'll get back to that, but let's take a look at the battery module first. Alright, well, I can still fit the UPS in the disc, more or less, with the battery module here. And yeah, I mean, like, these are so bad off right now. Now, that could also be indicative of a bad charge voltage or bad power supply for the battery charge, because it could be overvolting these batteries and just cooking them. Hopefully that's not the case, but I will check that when I get the new batteries in there and make sure that this isn't pushing a higher voltage than this module should have. And by the way, the nominal voltage for this, these are all 12-volt batteries, so it's going to be 6 batteries, 72 volts. And the peak voltage is actually higher because these batteries will be charged to, according to their specifications written right here, 13.5 to 13.8 volts. So you can't really read that, but here it says 13.5 to 13.8. And actually I had to use the calculator for that because 13.8 times 6 is 82.8 volts. So with a fresh battery pack, you could very well have over 82 volts DC on here, again, with a lot of current being able to be supplied by these batteries, and a lot of short circuit current. So you don't want to accidentally short out the DC coming off these batteries, either, you know, on the pack or in the unit when you're messing around in there. So again, always disconnect the batteries before messing around inside here. Now, all that being said, why did I turn this off? Now I just have to wait a million years. What is this from? This fell out of the UPS, but I'm sure we have pretty much 0 volts off this right now. Oh, you can't even see that. Okay, 2.02 volts now and falling. Just falling over the resistance of this meter. I mean, these batteries are absolutely shot, which was obvious from their physical appearance. If you ever run into batteries that look like this, that are wavy on the outside or bulged or bloated, they're bad batteries. Don't even try to mess around with them. Don't try to bring them back to life by trickle charging them. Throw them out in an environmentally acceptable manner, whatever. And I'm just going to bring this up here for a second. You can see all we got basically are jumper wires between the batteries. Oh, I should have pointed out, I mean, obviously, if I said these are 12-volt batteries and you're getting 72 volts out of here, they're wired in series. That's not the case for all UPSs. Some might be wired in some combination of series parallel. Usually, they're going to be wired in series. Although, I shouldn't say usually, because some manufacturers, especially the consumer-grade UPSs, like your cyber power UPSs, your small ones, your small APCs, some of those operate at 12 volts internally, because if they sell that model with a single battery, a very low capacity, low runtime type of UPS, they might sell a slightly higher model with a longer runtime, maybe even a higher volt amp rating, which is kind of BS, but anyway, and they might just wire two of these batteries in parallel and still have the UPS operate at 12 volts on the DC side, but it'll have two batteries wired in parallel rather than series, so it's not always series, but for these higher capacity UPSs, they're usually going to be in series because, well, quite simply, it's more efficient to convert 72 or 83 volts to 120 volts rather than converting 12 volts to 120 volts. So right now, I don't have to worry too much about, doing something dumb and accidentally shorting these batteries out because they're dead. And, oh, there we go. Oof. Yeah, they're so bulged that they really like jammed in there. It doesn't really matter which battery you take out first. You do you. In fact, I would recommend always using pliers, not necessarily these angled pliers, these are just what I had handy, but always using pliers to pull these out in UPSs, because invariably you're going to wind up in a situation where like one of these is on there real tight and you're trying to pull it off, and there's a little bit of sheet metal like right near your fingers. Like let's say I was doing this and your finger is going to slip, this connector is going to come off, whatever, and you're just going to slice yourself on the metal. That's happened to me. That's why I bring that up. Especially on those, again, I hate to keep bringing them up, those APC models behind me. Those are just the ones I change the batteries in the most. So that's why I'm so accustomed to them. But I've had that problem with them. There's a lot of relatively thin steel right around the batteries. And if these are tight, just give them a little wiggle side to side. Yeah, see how that just spranged off? If that was my finger along there. Painful. Yeah, just to give you a better idea of how jacked up. Well, it's not even that bad on this side, actually. Well, it's a little wavy. But on this side, wow. And just by comparison, this is what a good battery should look like. If you look at the way the light's reflecting off of this, see there's a slight waviness to it. That's just the way it's manufactured. That's fine, but for the most part, it's very flat on all six sides. And by comparison, not so much. That's of course to say nothing of the voltage, which let's just test one of these in isolation. I don't know why I keep turning this meter off. It takes so long to power up. Yeah, 0.27 volts. And as for this brand new one, 9.2. It's actually not that brand new. That's a little lower than I'd want it to be, but that should be okay. It should be able to top that off, and this battery's probably not permanently dead. Another thing I wanted to say is that sometimes these wiring harnesses can be relatively complex. They can be intimidating because you end up with wires going everywhere. And if you unplug all these connectors, you're just going to end up with a bunch of jumpers, like this one, for example, just lying around. And if you mix them up, the problem is with a wiring harness like this, you might not remember which one goes where, and it's not really important because if they're just wired in series, you're just going positive, negative, another battery's positive, let's say this one, and then another negative on that side. And the batteries are just all wired one after another in series. So as long as you know that, you can make up a wiring harness that works. The problem is that the way they're configured physically, you might have to use certain jumpers in certain positions in order just to have them reach from battery to battery. So one way of avoiding all confusion, especially with a nice open frame like this, is just when you pull a battery out, put a fresh one in. Fresh being relative in this case, because this one's, I don't know why this voltage is 9 volts on this one, but to be honest, it's been sitting down here for a while. And another thing, these usually ship with the tabs like sort of pointing up at an angle. I always flatten them down. Sometimes you'd need to. They won't fit in the frame here unless you push them down. But it can just make things easier on you. And now these batteries are so inflated, this one's not dropping in there nicely, but that's okay. We'll just leave it there. I'm just going to go through and disconnect each battery and reconnect it. But again, if you lose your way, if you end up taking this apart first, just remember jumper negative to positive, positive to negative, negative to positive, all the way around until you get back to this red wire attached to a positive terminal and this thick black wire attached to a negative terminal. And then you should be fine. The only thing I guess you want to be careful about is that you're absolutely sure where your wires are going and you don't mix a couple of them up and accidentally, just jumper a battery and just dead short it. Or worse yet, you're going through the packs, and you're like, I think this wire connects to this battery, and then that actually creates a short circuit across like the entire pack or half the pack, in which case you're going to have quite a meltdown on your hands because none of these wires are fused, so they will be the fuses. Or the battery will be a fuse internally, maybe a fire. But low voltage DC is no joke. Because, look, with low voltage DC, I mean, you could bridge 2 terminals with your fingers. That's not going to overcome the resistance of your skin. It's not going to shock you. It's not going to electrocute you. The same, if you touch 2 terminals of a car battery with your fingers, you're not going to get a shock. Nothing unpleasant is going to happen to you unless you're wearing jewelry. So, don't just do that. But if you bridge 2 of these terminals with a piece of metal, like, for example, even if you just drop a screwdriver in here and it lands in an unlucky way, you could very easily accidentally short 2 of these out, or more, depending on where your fault is occurring, and you could wind up with a hell of a lot of current flowing through whatever metal is bridging these 2 terminals. Now, I did get all these batteries about the same time, so I'm going to go out on a limb and assume that they're all at 9 volts right now. I must have bought these much longer ago than I thought they did. This is not a ding on refurb UPS. 5.2 volts. I had this other Cyber Power branded ones sitting around 11 volts. We like 11 volts. That's not bad. As you can probably tell from this video, I don't usually buy the branded batteries, but I think I got a few Cyber Power branded batteries on sale for about the same price as just these generic ones. I should note these are just generic ones with a Cyber Power sticker on them. I'm pretty sure I don't want to say that the wrong way. Let's call it Rytar. Yes. And when you're done connecting all the batteries, it's easier on some battery packs than others. Like this one, it's kind of difficult, but always just recheck all your connections. Make sure they're pushed in all the way. Make sure everything looks snug, that none of the wires are being crushed or impinged upon. And also, I'm not a big fan of this bend radius here. That's a really tight bend radius. Let's see if I get a little more slack on that from the other side. At the same time, I recommend using pliers. You also do have to be careful. The pliers can chew up this shrink wrap a little bit, which, it's putting dents in it. It's not actually breaking it, but do be careful. I don't like how loose these are. That's another thing, by the way. Very light insertion force, and more importantly, very light removal force. Just give it a little pinch. You don't want to over pinch it, but you just kind of want to crush it down the middle. Then it should be a little hard to shove on, and it shouldn't come off too easily. Alright, and there we have our battery pack. Just make sure that everything is good, that all these connectors are firmly and fully inserted. This wire should be on the underside of these flaps. Make sure everything can lay flat. Right now they're just pushing up gently, but when I put the rest of the frame on, it's going to hold that in place. And check each one individually and make sure you get a good visual inspection. You can actually see each terminal and that they're all connected properly, which they are. Remember I said I found this piece? It actually came off the lid. Here, let me show you. Around there. It's anti-chafing. Not really sure why it's needed here, but hey, let's put it back. And before I screw it shut, actually, all the way, let's just check the voltage on this connector. 55 volts, let's call it. And 55 divided by 6, well, it's close to 60, so should be a little less than 10 volts per cell, which we're measuring about 9 on some, 11 on another, blah, blah, blah. So that at the very least means the batteries are connected correctly. It does not guarantee that our connectors are all pushed in all the way, but I did double check that, so we should be good there. Oh, so what I was saying before about not leaving any of those connectors loose on the inside and the battery terminal connectors is that if you don't connect it all the way, if you don't push it down all the way, you could end up with a high resistance connection right there. And that might not be able to carry the amount of current that this battery pack is putting out. And the problem is, I mean, you could end up with that connection getting incredibly hot. And of course, that heat would be generated at the terminal of the battery, which means it would be going right into one of the electrodes and potentially heat up that entire electrode, boil the electrolyte in here, and create all sorts of bad problems. At the very least, your battery will fail. At the very most, I don't want to be alarmist. It probably wouldn't start a fire because it's in a metal case. You know, these batteries aren't particularly susceptible to spontaneously combusting. Again, they're not like lithium-ion batteries if you treat them badly, but you could very well end up killing the whole pack because this whole pack being stuffed inside a metal box would just get hotter and hotter, and when these batteries are subjected to high temperatures for a longer period of time, it is not good for them, and it will kill them. Although, I guess to cover my bases legally, I mean, it could start a fire, it could, I don't know, destroy everything you own, and bring harm to your entire family. So, you know, be very careful. Again, don't mess around with high amperage DC, even if it's low voltage, and low voltage seems safe. Let me get these rotten, oh man, the bottoms of these too. Let me get these rotten batteries out of the way. Trying not to knock everything off my bench with the ass end of this UPS. But anyway, let's let it Cookie Monster up this battery pack. Connect the battery connector. And now, let's power it on and see what it has to say about that. I have a feeling it's still going to complain about the batteries because the pack voltage is going to be too low, but I'm hoping it'll charge them anyway. So, there we go. Alright, that's a piercing alarm. I mean, don't get me wrong, it should be a piercing alarm. That's not really a criticism, that's just an observation. By the way, I have these two UPSs sitting in tower configuration. That's why the display is angled this way. But you can simply squeeze two tabs on the top and bottom of the display and rotate it and then snap it back in. I can't rotate it because the table's in the way, but that's the idea. In fact, I'll probably just zoom in, enhance, and rotate this. This is actually a good angle for me to look at it because my head's like looking at it from here. But I'll rotate this and zoom in so you guys can see what I'm doing. All I want to do is see if I can like recycle the battery. Let's just run a battery test and see what happens. Unallowed because the voltage is too low probably. Shouldn't that be disallowed, or is unallowed the more correct way of saying that? I don't know. Power 35.1 megawatt hours? Is that the aggregate? Have I? No, there's no way I've run 35,000 kilowatt hours through this thing. I mean, I didn't get it brand new, but still. I was hoping it would show, like, battery-specific stats. I mean, it did show battery stats here, but I was hoping it would show... It's showing a zero... It's showing 0 volts for the battery pack voltage. I mean, it might just be because it's below its threshold to measure, but the connector is connected. I'm going to try with the UPS on. Completely disconnect it and reconnect it. Yeah, I just think the battery voltage is too low for it to even detect, maybe? You know, like... I could see it saying 0% capacity, but not 0 volts. Like that... that doesn't seem right. But let's double check. I don't think any of the connectors work their way loose in there in the meantime, but maybe. Nah, still getting 55 volts. Well, this is an unfortunate state of affairs. The batteries I put in this, I knew have been sitting on the shelf for a while. I tested them I feel like a couple of months ago. At least I tested a couple of them, and they were reading 12 volts. So, I guess I just left them there a little too long. like I said, they're not shot. They can still be recovered. It's just I don't think the UPS wants to mess with them at that low voltage. So what I'm going to do is get a bench power supply that's, if I have one, that's capable of outputting like 60 something volts, and I'll just try to float them up under a low current, like a trickle current, overnight, and just bring it to a level where the UPS is going to detect the battery pack and then charge it the rest of the way. That's the idea anyway. Yeah, well, I get that set up. I'm going to leave the UPS plugged in, actually, in case it decides to float up the voltage. Yes, I'm going to connect the pack for now. It's saying the battery's bad, so it's probably not even going to try to charge it. Usually, UPS won't try to charge a battery pack that it thinks is bad for whatever reason, because, again, the cells could be completely foobarred, like those ones over there, and it doesn't want to overheat itself or start a fire. All right, well, it's been a couple of days. I got a haircut. What else happened? Nothing you'd care about, except for this, the batteries. So here's what we got going on with this hot mess of random wires everywhere. Well, they're not random at all. This is, well, the colors are kind of random. I'm sorry about that if you're anal retentive about that sort of thing. Right now, the batteries are charging off of these two bench power supplies. Why two of them? Because I'm charging the batteries in series as they're set up. I'm charging the entire pack at once. And to get it to an acceptable voltage, I say acceptable because there's actually a range of voltages. Sealed lead acids are not as finicky as lithium ion, so you got some leeway. Anyway, I'm targeting right now 83 volts. So we got 30 volts on this side of this PSU, 30 volts here, and 23 volts here, for a total of 83, 60, and 23. They are all wired in series. Well, these two halves and then this power supply, so hence the 82.6 volts. Now this is measuring the voltage at the battery connector, and so there is a bit of voltage drop, so you can see we got 82.6 blah blah blah. Don't need such an accurate meter for this, but you know, that's what I had on the top of the pile. And here's what we got going on at the battery terminals. A very safe way of connecting them. I just shoved two wires into the ends of this connector and put toothpicks in to hold the wires in place. It's just bare copper on the end of these two. And then, of course, we got these two little clip connectors, which are just going to the multimeter. So negative and positive. Yeah, even though I'm using blue as negative for all these other... Well, anyway, it doesn't matter. The point is, power supplies coming in on these two wires right here, and voltage monitoring on these two. And I did put sticky tape on either side, just in case the toothpick pulled out so nothing shorted. Not really the recommended kind of tape, but I mean, in theory, electrical tape would have been better, but the problem is it's not transparent, so if the wire did start creeping out, you wouldn't actually notice it. So at least now you could see that everything's in order in here. Speaking of not shorting stuff out, or rather protecting myself from shorts, this positive lead coming from the power supply has both a fuse. This is an automotive fuse. I just happen to have some wires with these pre-installed in line, and this is the lowest value I had, which is a 5 amp fuse. Really just to prevent short circuits, or rather to cut out in the event of a short circuit. And this is just a 100 volt 5 amp diode just spliced into this cable. And that's to prevent the battery pack from backfeeding into the power supply. Now this PSU should have reverse polarity protection, I got to imagine. But, you know, also for safety this way, if I leave this lying around on the bench, and it hits something that completes the circuit, we shouldn't get any voltage flowing in this direction. But just in case we do, or something else disastrous happens, there is a fuse. So I feel like the fuse and the diode is the safest way to do this, especially with an extremely high amperage, high voltage battery pack like this, with 6 of these SLA batteries wired in series. And these batteries were almost certainly sulfated. That's the buildup of lead sulfate crystals on the electrodes, which prevents current from flowing, or at least heavily impedes it. And we could see that when I started charging this, I had the power supply set to a variety. I tried a variety of voltages. I stepped it up a little bit because I was only getting 10 milliamps flowing into the entire battery pack at first. Went up to about 20, then gradually up to 50, and then a little more quickly than that over the course. I think I left it overnight actually, so maybe not that quickly. It eventually did reach the power supply's current limit, which I had set to 0.5 amps or 500 milliamps. And that's a fairly low current for these batteries to charge at. The idea is I wanted to charge them low and slow. I probably should have, to defeat the sulfation, I probably should have let them charge even slower at a much lower current, maybe only like 50 milliamps for like days and days at a time. I don't know. I did what I did. To be honest, I already got fresh batteries for the other one of these UPSs that I have, because I didn't have batteries for those. And these I just left on the shelf way too long. Even if I could bring these mostly back to life, slow charging I don't think is ever going to clear all the sulfates, all the sulfate crystals off the electrodes. It's never going to bring the batteries back to like 100%. I was going to say 100% efficiency, but 100% of their previous efficiency. And so for UPS, that's not really desirable. Like, I'm going to test it right now. These batteries are just about fully charged. I'm going to connect them back to the UPS, and I'm going to put a load on them and just see if the UPS runs for a decent period of time. And we'll see what the runtime estimate on the UPS is, and see if when I first plug in the load and with the batteries, and see if it actually matches that estimate. Because it'll make that estimate based on the voltage of the battery pack at the time it's measuring it. But if the voltage collapses, that estimated runtime will dive straight down along with the battery voltage. But the initial voltage should give us an idea of what the runtime would be if the UPS had fresh batteries in it, because that's what it's expecting. Yeah, so let's do that. And there we go. Now with all that stuff cleared out of the way, plug the battery back in. Should be good. I should be able to start it up on battery maybe. I don't know if it has that. Yeah, I can. And so now the batteries are under load, obviously, because they're supplying power to the UPS itself and, this fan and other gubbins inside. So AC not available. Start on battery. Oh my god, this input lag. Yes. So that'll turn it on. Now, we're not seeing the battery alarm, which is good. I am going to plug it into AC for the moment. Silence alarm. Okay, there was no need for an alarm. Load on inverter. Outlet 1 closed auto manual. Outlet 2 closed auto manual. So, point is, UPS is started up. Like I said, I want to put a load on it. And that load is going to be this space heater straight off the floor of the garage. I was going to almost say the garbage, because it's covered in garbage. Well, it's not like garbage, it's just like some old grass and stuff that gets in under the garage door when the lawn is mowed and stuff. But anyway, there we go. It's kind of nasty. Maybe it'll go on fire and we'll have some fun. Probably not. And I think this can draw, 1500 watts max. And it's got 2 heat settings. So let's bring it around back. Plug it into one of these nastified plugs. There we go. And now if I turn the heater on, I'm going to turn on low first. The lights in the basement just... Oh, I don't even know if... Well, we're going to run off battery anyway. I was going to say, the circuit that this is plugged into right now is running all the studio lights down here in addition to some other stuff. So putting 1500 watts through the AC power supply to this, or the AC circuit that's powering this, might not be the best idea. But like I said, we're going to run off batteries. I just wanted to start it up. Let's see. We're currently showing a load of 31%, which should be about 1000 VA. The advantage of this also, by the way, is that it's a resistive load. So except for the fan maybe, but VA and watts is going to be the same for this, voltamps and watts, because it's going to have a power factor of pretty much 1, like I said, other than the fan, which is minimal. So our output power is currently 7 amps, our input power is 8.4 amps, and that's all at 117 on the input, 120 on the output. And it's estimating 19 minutes of runtime at this load. Oh, and I should point out, this is at the low setting, but 7 amps times 120 volts is 840 watts. So this is pulling 840 watts right now, which I guess is as good a place as any to start for the load testing. So let's dump it onto battery and see what happens. UPS battery low and... oh, wow. Okay. Can I silence the alarm? Battery low and cannot be silenced. Okay. Well, that's annoying for a video. I mean, normally you want to know, but... And it says battery 0%, so the voltage must have dropped precipitously on the battery. So yeah, it's pretty much saying that it's going to die any second now. Still putting out 7 amps, though. Nope. the heater just cut out. The power is still on the UPS, but it could no longer support the load. And now the UPS died, which is kind of what I figured. So yeah, these batteries are pretty shot. So I guess I'll have to order another batch of batteries. These fortunately are not as expensive as the APCs that I was talking about before, because it uses, well, fewer batteries. The batteries in the APCs are smaller, but the APCs use 16 smaller batteries, and this uses 6 batteries that are roughly twice the size and twice the amp hour capacity. Point is, these were $130. So I'll just order a new set for this UPS and dispose of these in a proper and environmentally friendly manner. Yeah, great. Of course, it's environmentally unfriendly of me because I'm the idiot that left them on the shelf for so long they went bad, and they never got used by anyone and will never get used by anyone. I'm not even going to try to recondition them, just because even if I did recondition them and they kind of came back, I don't know what I'd use them for. I don't want to put them in a UPS because, you know, I want good batteries in a UPS. Well, anyway, enough of that. Let us open it up and have a look inside. Oh, and like I said, even though I have the new batteries right now, I'm not going to show myself installing those because the installation process is going to be exactly the same as installing these no good batteries. There's nothing wrong with the installation of the batteries. Me putting the pack together went just fine. It's just the batteries themselves that were jacked up. So unplug the battery pack, of course. You can see the connectors there. And just always, even though I'm the one that pulled the plug just before, always double check and make sure it's not plugged in. Also, if you have a rack with a bunch of UPSs in it and they all have identical plugs, make sure you got the right plug. That's why I always color code my plugs. And the UPS is obviously color coded. The other end of the cord is the same blue zip tie and blue tape. And then on the front bezel is the same color tape as on the plug and on the cord here. So from the front of the UPS, from the back of the UPS, from the other end of the power cord, I know what I'm working with. Because it's happened to me, and it'll probably happen to you if you mess around with stuff often enough. I mean, not with the UPS in particular, but, you know, where I pulled the power on something that I thought was the thing I was trying to pull the power on, and that thing was still energized, and then things got a little dicey. So that's one of the reasons why I always label my power cords. Even these guys, because IEC cords all look pretty much the same. I mean, this one's red, which is unusual, granted, but I have a bunch of red ones. And hence, this is white with yellow zip tie. And they all have different color combinations on them. And before I open it up, I'm actually going to remove the battery pack completely, not for any kind of like weird safety reasons, just because it's going to make this a hell of a lot lighter to move around. When these batteries shipped to me, and it feels like about right, it did say 40 pounds for the ship weight, and then this would be even heavier with the metal case around it and the wiring. So, yeah. I'm actually not sure how heavy the UPS is with the batteries installed. It has this warning sticker that it's greater than 18 kilograms or 40 pounds. That greater than, I think, is doing a lot of work there, because I think the UPS empty might be 40 pounds. I don't think it's 40 pounds without the batteries. It's still pretty hefty, though. Now that begs the question of how do we open this up, which I haven't done before. The only two screws I'm actually seeing that are connecting to the top are these two torque screws on either end, so maybe the top just slides back. Let's investigate. Oh, there's one in the middle too. Almost didn't see that. Oh shit, I see what happened. Alright, well we have the little monitoring card with RS-232 and LAN ports, and that is actually impeding the top from moving out. Starting to not like that they can't keep their screws consistent here. Like, just use one screw head for all the screws. I don't care if it's Torx, I don't care if it's crosshead, whatever. It looks like that was the same as the screw that went in here. So maybe someone else messed up the screws. Although no, because these are countersunk on the ends, and this one's not, so yeah. There we go. What have we here? A lot of dust just flew out when the cover came off, although I'm sure that surprises no one. Is this paper? Well, it's a little thicker than paper. But yeah, quite dusty, especially in the back there. So I'll be cleaning all that out. Sorry, in the front. Oh, and by the way, management card looks like this. Maybe we'll take a closer look at it later. Looks like we got a huge filter here on the output. It's kind of a rat's nest of cabling back here. The top cable here is the power inlet, the one that's actually able to wiggle the wiring inside, which I don't really like, because if that wiggles the connectors those wires are in, that could loosen things up over time. Although, how often are you moving around your UPS, right? Well, I guess you could install one of these in like a production truck for television or something, where it might be bouncing around a little bit. And the bottom is this here. That's crazy. The neutral on the inlet just goes straight onto this PCB that's down there. Why don't we try to get a better view? So this red screw right there, which is a regular screw with marker on it, that's the neutral from the mains input. And it just looks like it's going onto this PCB right here. So this PCB must have some thick-ass tracks, because at 3,000 volt amps, and let's say the nominal voltage is 115, which sometimes it gets down to in North America for sure, maybe even lower sometimes, that is 26 amps of current. And I think that's the 3000 VA is the power capacity of, I believe, the output side of the UPS. And so the input side could draw more, and in fact would draw more due to inefficiencies in the double island conversion, and if it's charging the batteries, those could be consuming a decent amount of current too. So this could draw up to 30 amps, I suppose, or more. I mean, it really shouldn't draw more than 30, because it has a, well, this is the female version, but it has a 30 amp plug on it. And it does have a 30 amp circuit breaker right here. That's this switch on the back, and this package right here. And is that connected? Yeah, that's this black wire right here is coming right off the mains and straight into this circuit breaker, and this circuit breaker is rated at 30 amps. Although, I should say, I was reading it off the back of the unit. On the back of the unit, it says 230 volts, 30 amps, right next to the circuit breaker, but the trip amps on this is actually 37.5. I don't know. That's not great. I mean, it seems like it would really stress out the building's wiring if the building's wiring was rated for 30 amps. I mean, it might trip the upstream breaker, whatever this is plugged into, but yeah, always be careful, because if the UPS has a faceplate rating of 3000 VA and you load it with, let's say, 2900 VA nominal, due to inefficiencies and when the batteries have to charge, you could end up really exceeding that 30 amp rating on your branch circuit that's supplying this thing. I mean, look, general recommendation is to never run a UPS near its maximum power capacity at any given time, or at least on a regular basis, because when your servers or whatever you have connected to this are at idle, if they're drawing 3000 volt amps, as soon as they're under load, they're going to draw more current than that, and this thing is going to shut down or get angry. And keep in mind, I should say, in credit to them, this circuit breaker might just be an absolute fail-safe in case something completely goes wrong, completely goes foobar with the circuitry in the UPS, because I'm guessing the UPS will shut down in an overcurrent situation. But just in case the circuitry in here fails, or something fails in all this area, it has this last-minute fire stop, or last-ditch fire stop, to cut power to this in a real disastrous situation. So I guess the 37.5 amp is probably to prevent accidental tripping. If this breaker was rated at 30 amps, technically the UPS should be allowed to draw 30 amps for periods of time, so you don't want this tripping at 30. That's my guess anyway. Now, while I'm in here, I just want to make sure, like, that neutral screw, yeah, it's nice and tight. I just want to make sure any of these high current screw terminals are not loose at all. What you also don't want to do is go in there and crank them down because you feel like, oh, better tight than loose. No, because they're probably torqued from the factory to a pretty exacting spec. So really, I'm just putting a fairly light amount of pressure on them just to make sure they don't wiggle, just to make sure I don't get any movement. I'm not going to apply any pressure in the counterclockwise direction because I don't want to accidentally loosen them and retighten them outside of their specification. Yeah, torque-wise, that is. Anyway, on the load side of this circuit breaker is this red wire, which is like weirdly like jammed in there and wrapped around this black wire. That also goes down to the PCB. And that looks like it has some, I don't know, metal oxide varistors, interference suppression capacitor, and inductor, I'm guessing. Or maybe these are metal oxide varistors, these blue packages. I'm not sure. And you know what? I'm not going to do a complete teardown of this because I want it to work and still be in good condition, other than, you know, cleaning out the dust. And just checking for bulging caps in particular. And this one, I don't like the looks of. It's not like super bulged or anything. No, actually, no, I think that was just the label coming up. Probably hard to tell from your angle, but from a side view, it looked like this was a little high in the middle, but that's definitely just the plastic. You can see it's squishing down there. And I'm sure these are good quality caps. Ew, what the hell? They're only 85 degrees C rated? That seems low. And they're not... Huh. These caps, this entire bank of capacitors, are outside the airflow of the fans. So we got a fan right here. You can kind of see the corner of it right there. Fan draws air in the front. Comes under this shroud. Gets kind of diverted in here. Then travels through here. And then out the back, where there's another fan, to pull the air out. So there's no airflow over this entire bank of capacitors whatsoever. There's no airflow over these capacitors. I guess as long as there's nothing over here generating heat, it's fine. I mean, these capacitors really shouldn't be getting hot in of themselves. Otherwise, there's a design fault. So I guess it's fine. I guess maybe I was overreacting. It just seems like in a power supply type situation, which this is in essence, at least in part, a big-ass high amperage power supply. Because when it's running off batteries, it's got to convert DC to AC. And so it's a DC to AC converter, but it's essentially, it's actually 2 power supplies, at least, maybe 3. Because it might have a separate power supply for the charging. Get this paper out of here without ruining it. No, this tab wasn't even in. There's little slots in the side here. Let me poke my blue tool through there. Yeah, without this wiring cover. Oh my god. Getting this on camera. Yeah, see there's a little slot there, and there's also one on this side. And this tab wasn't in that slot. Not that it matters. That's really not a big deal. And then is this, hold on, no, it's a little plastic rivet right there that's holding on this, I don't know, it's probably not wax, but it's like waxy cardboard to make it moisture resistant, I guess, so you don't get mold inside the UPS, or so it doesn't degrade if, you know, a little bit of humidity and moisture gets in here. Not a lot of, I mean, if a lot of moisture gets in here, you're probably screwed anyway, but, you know, in a humid environment. I just wanted to zoom out a tad so that you can really get some context of what we're looking at. So like I said, this board is the filter board. These 2 lines are the output from the filter board. So in other words, mains. This is just mains voltage coming up here. And you can see live. I'm hoping the red is live. That would make sense. Or a line. And neutral is over here. Again, just clamp down to the PCB with screws. And again, just a quick little check. I don't know if it's a rivet or like a clip. I think it's just got those serrations that let it friction fit in. I'm not going to cut it. I'm just using the side cutters to lift it, hopefully. Oh yeah, there we go. It's just got those little expander dealies on the side, just friction fits in there. Cool. Because I just wanted to be able to take that out of the way. I mean, fortunately, these heat sinks aren't too groated up or anything. Aside from a little bit of just dust on the end there, these heat sinks also aren't as bad as you'd think. But we definitely want to get the dust out of there. So, yeah, let me take off all these little cardboard shields, or air baffles. Now, fortunately, I'm recording this for YouTube, but if you're going to be doing this with any UPS, just take some pictures before you take all this stuff off. Just because there might end up being a couple of pieces of like this, you know, cardboardy material that look very similar and you don't remember which one goes where. And can I remove this entirely? Is there... Oh, yeah. Oof. Look at that. Nasty. And then for some reason they went from this black material, which I'm guessing is very insulative, but then they, like, spliced it onto this white material rather than just sticking with one material throughout. I'm sure they had a reason for that. Like, their engineers aren't stupid or going to do things without cause. probably. Oh, and it's actually got a double flap on this side. So that's got a... Yeah, I mean, it's a good way of interlocking these. Oof, you can see how bad it is around that fan, though. Damn. The fan is so grody, I might want to replace that. It's a 12 volt, 0.4 amp fan. What the hell is the branding on it? DWPH. I've never heard of that brand. It's probably super popular, and you've all heard of it, but I haven't. And what is this? This looks like a power supply board. And we got a bunch of relays down here. Well, probably a couple of capacitors too, but relay, 12 volt DC, 30 amp, 277 volt AC. Yeah, they got to be relays. And we have another chunky transformer looking thing here. It's got very thick windings. I thought it was maybe an inductor at first, but it's got 4 connections, at least on this side. Yeah, nothing on the other side, but 4 connections on this side, so it probably is a transformer. Now, maybe it is being used as an inductor, because it's got 2 of the windings terminate and are spliced together before they enter the PCB. Anyway, we got a lot of transistors, or I don't know, thyristors, whatever the hell they are, all along this heatsink here. A few more on this heatsink here, I think on both sides, yeah, on both sides of that heatsink. And probably some more down here, because there's another heatsink on this end. This video's already gone off on like too many tangents, so I'm gonna take this piece out too. And I'm no expert in the internal operations of this UPS. This is the first time I'm looking at it, so yeah, I apologize if you're looking for like a full explanation of what everything in here does and how this whole thing works. I am not going to be the one to provide it to you because I don't know yet, and by the time I did figure it out and then show it to you, this video would be 3 hours long probably. This looks like a huge-ass full-bridge rectifier underneath this heatsink, because it's a square package, very large. It's almost as large as the heatsink, and it's got 4 pins on it, and they're very thick pins. So it's probably a very high current full-bridge rectifier. Like I said, I'll call them out as I know them. And then we got these wires here that are running the entire length of the chassis, and these connect to the battery expansion port on the back, which says battery connector 72 volts DC, 37 amps. And those terminate up here, and they're on a common negative. The 2 black wires are common together before they enter the PCB, but the positive is actually on a different leg, on a different connection, because the internal battery pack connects down here. I mean, you couldn't really see it from the angle, but you also can't really see it from the dust, but it connects down there. And that's the only reason that's interesting to me, is because I would think on like a cheap UPS, or even, you know, a slightly more expensive UPS where they're just trying to keep costs down, they might just put the internal battery pack in parallel with the external battery pack, which would result in the same voltage going into the UPS, but provide a lot more amp hours and a lot more current handling capabilities, which isn't really relevant. The overall current handling of the UPS would still be the same. This might actually be able to monitor the external battery packs separately, which is kind of cool. Because I'm wondering if, first of all, it might charge them sequentially rather than trying to charge both packs at the same time. That might be to limit current on the charging power supply, which might be this, because this looks like a self-contained power supply, probably switch mode power supply, because we got a transformer, we got a big diode right here on the end. This looks like the secondary side probably, and a big capacitor here, which is rated, well, I can't tell. But anyway, I'm wondering if this is the power supply for the charging, so it might make sense to sequentially charge each battery pack. And it might also make sense to sequentially run down each battery pack, rather than drawing current from both of them simultaneously, running them in parallel. So I wonder if that's what it does. I guess I could check the manual when I edit the video. This down here is the monitoring card. I don't want to call it the management card, because that's really more of what this is that came out of this slot. That goes right there. I was just waffling about it, but I guess this is the management card, because it has a USB port and some analog switchable ports on the back. But yeah, if you can run the UPS without this card, obviously. So this was probably all the logic for the UPS. These 2 ribbon cables going here and here, both just plug into the management card. So yeah, I'm guessing this is the main logic for the UPS, main management. This just has the purpose of adding serial port and LAN port to it. Looks like a couple, these are probably, these two boards standing up on here. It's got a capacitor, an inductor, some resistors. I'm guessing these might be DC to DC converters to provide even lower voltages for the circuitry on these cards. Yeah, without taking the board out and like actually tracing it out, I don't really know what these are powering exactly. This also might be another power supply, but like low current power supply. Oh, by the way, there is a very long ribbon cable running. It's actually this connector right here coming off the management card. It dives under the card and then is folded and kind of runs vertically along the entire side of the chassis, gets folded again, and then you can see it right here. It's actually in this, well, it looks like heat shrink tubing, but I'm guessing it doesn't shrink. This rubbery looking flat tubing. Is flat tubing an oxymoron or a contradiction? I think so. But anyway, it gets folded, it goes flat underneath the fan, then it gets folded again, comes up here, and eventually goes to the front panel, which you can remove and turn 90 degrees, so there's a little bit of extra slack there. Crazy long ribbon cable. It's covered in the same stuff as these two ribbon cables. But anyway, yeah, so that's the UPS. I am going to bring it outside. It's very late at night right now, so I'm not going to do it this minute. But now that I have it open, tomorrow I'm going to take it outside, blow all the dust out. The thing is, when you blow all the dust out, and especially when you blow the dust in the fans, sometimes that can drive dust into the bearings of the fan or into the, you know, inner workings of the fan, and then gum up the fan. The fan dies very shortly afterwards. And this thing is so filthy, and it's been running for like probably 10 years anyway. I think that might be just good preventative maintenance replacement. Should be pretty easy because, you know, it's a fan and it's actually on a connector. So yeah, let me order fans with the same specs. I'll go with Sanace. I like Sanace. They're usually pretty quiet and very reliable in my experience. But ugh, yeah, look at that. Anyway, so for you guys, I will be back in a second. For me, I will be back tomorrow with this thing nice and clean and shiny. Well, at least with most of the dust gone. It doesn't have to be absolutely pristine. I mean, some people get anal retentive about it. I've seen people like clean out equipment online. It's not like this is a freaking showpiece that's going to go in a museum, and as soon as I put it back into operation, it's going to start inhaling dust again. So really, I just have to get it clean enough that there's no obstructions on the heat sinks, there's no obstructions on any of these components that for airflow, I mean, and these fans are both replaced so they can provide that nice airflow. But in 10 years, it will look the same. So I'm not going to go in here with a toothbrush and scrub the heat sinks down and make them look perfect. I think that would just be insane. I'm going to blow it out with some compressed air, and anything obvious or, you know, really obscene, I'll give a wipe down with a damp cloth and move on with my life. You know what I mean? I don't think it's worth stressing over. Oh, I guess the only other thing of note a little bit is that the UPS does have the ability to sequence or control the receptacles on the back here in groups. It cannot control this one independently, but it does have two relays on this board, one up here and one down below it. And those relays, I believe, are signaled by this cable, which goes back to the management card. And in the menu system, you can also choose load shedding options. So like if the UPS is over current, like if there's too much current draw, or as the batteries get below a certain level, I believe, especially with the web management interface, you can set it to shut off. It looks like these two receptacles at once, or these four receptacles at once, in order to reduce the load on the UPS. So you can put your least essential equipment here, for example, your second most essential equipment here, and your absolute most essential equipment here. So this way it'll turn, you could have it turn this off, and then these two. Also, it can power sequence when you turn the UPS on, so you're not instantly powering up all the, for example, computers that are connected to this UPS, where they might have large capacitors in their power supplies that draw a hell of a lot of current right away, which could overload the UPS or even overload the branch circuit. So by turning on, you know, well, this would come on with the UPS, then turn on these receptacles, then these receptacles. This way it would just sequence in the power draw rather than just poof doing it all at once. I like that. Alright, these are now significantly cleaner than they were, but I'm glad I took them outside, because, man, there was a lot of dust in every nook and cranny down here. And in case you're wondering what I'm using for the dusting, it's this thing. I don't know that brand even exists anymore. I got this years ago off probably Banggood. But, hey, still works great. So if you see something in this general form factor, it's probably pretty reasonable. It's got a really powerful airflow. Better than the canned air, because obviously this is rechargeable, whereas the canned air is not. And it's easier than breaking out the air compressor. Well, what I've got here on top of this envelope is just some damp paper towels, because I still got to clean off the paper, I guess, from inside of it. I think the white stuff, I'm 90% sure this is just cardboard impregnated with some kind of anti-moisture stuff. I think the black part is plastic, though. Not 100% sure, but you can see it's still got some dust on it. I want to be kind of gentle with it and not soak water into the material. I mean, with the plastic, it's not going to matter, but particularly with this impregnated cardboard, I feel like getting that too damp will cause it to degrade. So these are just, like I said, damp. Yeah, and I'm not looking for perfection. I mean, no one's going to see this. This is just going to be inside the thing. I just don't want any dust to come off of this and just get right back into the heat sinks. And speaking of sinks, I did take the front bezels over to the sink and just wash them out, because there's no electronics on them whatsoever. So completely fine to get them soaking wet. Yeah, there's a couple of metal pieces that clip them in the back. So, you know, those could in theory rust or something, but I think they'll be fine. Alright, good enough as far as those go. Next is the top covers, which, as you can see, are pretty dusty. And like I said before, I'm not looking for a brand new, like, showroom, well, UPS showroom. I don't know where those exist, but a showroom fresh kind of look, because these are just going to start accumulating more dust as soon as I put them back into service. And as you can see, I didn't do a great job cleaning the fans, especially this one, but that's fine, because I'm going to be replacing the fans, as I said, and also taking this front protective cage off and cleaning that in the sink. So the front of these will be fine once I'm done with them, at least more or less. So speaking of fans, I'm going to hoik the old ones out. And yeah, here's the dirty ass fan. And you can see it's a 2-wire arrangement, so no tachometer, no PWM. It's just straight 12 volts. I don't know, they might be moderating the voltage. And it's got this 3-pin connector, but only the outer 2 pins are used. And I just got a DigiKey shipment with what are hopefully compatible fans. When I say that hopefully they're compatible, what I mean is they're 12-volt fans, so the right size. I just, for the life of me, could not find specs on these fans, like airflow-wise, static pressure-wise. So I just picked some high-quality fans in this form factor at this voltage with the highest static pressure and highest CFM, approximating the power draw of these. These actually draw slightly less power, but I think that's okay, because no specs at all on these. And a nice brick of fans. Now, I only need 4 of them, because each UPS takes 2. I got 6, just because I usually like to over-order fans, especially like good quality ones, in a fairly standard form factor. I forgot what dimension these are. I'll put them up on screen right now. Like I said, I've had great luck with SanAce fans, so... And just to double check, they look like they're dimensionally accurate. And just to double check, 12 volts, 0.37 amps. These are 12 volts, 0.4 amps. So very much in a similar spec. Bit of a different blade design, as you can see. But like I said, high static pressure, high CFM, so these should be okay. And also low noise. I think it was like 40 dB, I want to say. Again, I'll put it up on screen. Sorry, I forgot the specs offhand. And then just come in here with a paper towel just to get all the remaining dust out of here. You can see there was quite a lot. It's pretty grody. It's pretty good. Of course, I'm leaving pieces of paper towel all over the inside of the UPS. That's not great. And of course, the only other issue is these fans come without connectors. I think I might have this style of connector, but if not, I'll just cut it and splice it. Alright, let's see what we got here. This is just the generic Amazon special cheap connector kit with crimp tool. You know what, actually, this isn't going to be very empirical, but I got a little bench power supply here. Kind of just want to see what the airflow characteristics are like IRL. I mean, it's hard to demonstrate it on camera, but it's pretty quiet. Blows a good amount of air. Decent amount of pressure. And just in case I do end up wanting to splice this connector, I'll leave a tail on that. Nice quality aluminum wires on these old fans. I'm just going to spray dust everywhere. Yep, a little bit. Again, not really scientific, but from my judgment, it seems like they're about the same amount of noise, about the same amount of airflow, maybe a little less static pressure, actually, but very close. Like, I think in a blind taste test, not taste test, in a blind field test, I'd have a hard time distinguishing between these two fans if you just blew them on me. So I think we're good. And this is just going in the garbage. It still runs fine. It's not making any weird noises. Like, the airflow is still good. It's just, I don't know how much life this will have left in it. So you could clean up the old fans. I'm not saying don't do that. And these fans were not cheap, but then again, these UPSs are not cheap either. So I feel like, why throw bad money after good? You know what I mean? I think these are the right female pins. All right. Then I guess let's just try it in the UPS to make sure it likes the fan. Then we can install this airflow facing out, just route the cables, or the wires rather, in a neat fashion. And you never want to leave fan wires just hanging out loose in here, because eventually that could, you know, twist up and then jam the fan. So always zip tie or otherwise secure them out of the way. And that is probably why these were secured to that thermocouple cable originally. And there we go. I've done the same thing. And now it's going to be essentially the exact same process for the front of the chassis as well as the other UPS. And the front fan has the exact same connector, exact same pin out, exact same model of fan. Everything's the same, so I'm not going to show that. And while I'm over on this side, I just want to show you there is another thermocouple right there, just in the path of the air intake. And there's the fan connector next to that thermocouple connector. It's kind of like, because of this cable though, it's not really getting good airflow over the thermocouple. But I guess that's for room air measurement, like intake air measurement. So I guess it would get baffled by this. And should get a good measurement. I'm sure they know what they're doing, unless this cable's out of place. And there we go. That is the finished product on the front. Yeah. Yep, that's spinning. Nice. And yeah, you can really see the difference now between this one and the old one, which was dustier in the first place, to be fair. But yeah, soon this one's going to look the same as this one. All right. And that is how all the paperwork goes in. One thing I had to change, though, is where I zip tied the fan cable. Yeah, that was really unnecessary because the fan cable can sit on this side of the shroud, and therefore it's not going to get fouled in the fan. And also, I had it pulled too far forward, so this couldn't slide all the way back, because it's actually got to be all the way back there. But should be fine now. So this UPS is all set. I just need to put the batteries back in and put the cover on. Alright, well, the UPSs are back up and running, full of fresh batteries in both of them, and these fans are quite powerful, maybe a little too powerful. They're a little louder than I kind of hoped for or expected. But you know what? That's okay. Better too much airflow than too little, I suppose. Here's the proof that they're working, but let me explain why I have the light bulb. These UPSs are going to be connected to an automatic transfer switch. Well, actually 3 of them. This one and 2 others that are already in the rack back there. And I did a video on auto transfer switches at one point. This is actually a little more than just an auto transfer switch. It's a PDU that allows for load ramping, load shedding, and individual control over all the output receptacles. There are actually even more on the other end here. But mainly my use case for this is going to be just as an automatic transfer switch. Basically, what that means is that it has 2 power inputs. And then, well, in this case, multiple outputs, although that's not really a requirement for automatic transfer switch, though you need at least 1 output for it to work. So these 2 inputs, in my case, as with many cases, are going to be connected to the 2 different UPSs. And the point of this is, as you can see, the light bulb is on. If I pull one of these plugs, the light bulb stays on. And you can see this LED here, the top one indicates primary, the bottom one indicates secondary. So I just pulled the primary input, therefore it moves to the secondary input. And there was no blink on this. The transfer is fast enough, maybe like 1 power line cycle or something, that you wouldn't actually notice it. Or rather, I should say your equipment wouldn't notice it, and a computer plugged in wouldn't reboot or anything. It would be as if the power was uninterrupted the entire time. And then if we plug the primary back in, this one actually takes a second to make sure that the primary power is good voltage and frequency, but there we go, switch back to primary. And now, likewise, if I pull the secondary, of course, nothing happens, and the light has stayed on. So that's the whole point, basically, is that you have redundancy. So anything that gets plugged into this automatic transfer switch will get power from either UPS. The advantage is twofold. I mean, one is for maintenance. I can take one of these UPSs completely offline, pull it off the shelf, add new batteries, clean it out on the inside, do all the maintenance I just did, while the other UPS carries the load. Or, since these UPSs are both fairly old by now, if one of them fails catastrophically, the other will pick up the load, or vice versa. So yeah, I just wanted to show that, how this is going to be used, and this is going to appear on top of the UPSs once I get them in position, so I kind of wanted to explain what that was. And like I said, I have 2 other auto transfer switches, and they are going to be used with these 2 UPSs and another APC UPS that'll be sitting next to these. The idea being that each UPS of the 3 will be a primary input for each of the 3 automatic transfer switches, and this way the load will be distributed amongst all of them in normal operation, and then the other secondary inputs will be shifted off by 1 to each of the other UPSs, so this way if one UPS does fail, it'll be 2 UPSs picking up the load from the failed one, not just 1, if you know what I mean. It won't necessarily be even because the loads aren't evenly distributed amongst the auto transfer switches, but it's better than just having 1 UPS completely at idle, not providing power to anything, and the other one handling all the load. Less stress on each UPS under normal operation. So I always recommend, well, not always recommend, but I would say that if you're going to have 2, especially large UPSs, and a lot of equipment connected to them, get 2 automatic transfer switches and have them in like a cross failover type situation, so that this way you're pulling power from both UPSs. Other advantage of the automatic transfer switch, of course, is that it, in this situation right here, would double the runtime of the UPSs, because when one UPS's battery dies, the other one will take over. That's assuming that the other one had no load on it, but even in aggregate, double the runtime. You got double the amount of batteries right here. Yeah, I guess time to get these off the bench and plugged in, attached to the network so that they can be monitored, and that's pretty much all there is for this video. So thanks for watching. I'm hoping it was at least somewhat helpful. A couple of little pitfalls here and there, especially with me having those, well, me being a dumbass and having those dead batteries that I put into it initially. But like I said, the battery replacement procedure is the same. Just use good batteries. And the batteries I did put into these UPSs were all new from refurb UPS. Again, it wasn't their fault the other batteries were bad. That was because I left them on a shelf. These batteries came with, one set was at 12.8 volts across, all 6 batteries pretty much. And the other set was at 12.6 volts. Either way, good batteries. I had a good charge on them. Oh, I guess I should test them out. I mean, let's go all the way, because I tried to do this earlier and it didn't really work out so well with the other batteries. So let's put a little bit of a load on it. Here's me trying to end the video quite prematurely. So there we go. We're up to, it's not really terribly visible on camera. Yeah, 6 amps. And right now that would be pulling it from this UPS. But here is the other UPS that it's not currently pulling from. And you can see right now on the input side, it's pulling 0.9 amps. Now that's charging the batteries, because you can see they're at 96%. They still have to be topped off. But output is 0 amps. Now if I pull that primary connection, and all I'm going to do is pull this connector right here, we should see the load on that shoot right up. I just pulled it, and 7.2 amps. There we go. And obviously it's not charging the batteries now, because it's 7.2 in, 7.1 out. So yeah, right now this filthy heater is running off of this UPS. Now, not batteries, because the UPS is still connected to AC, but now I'm going to pull the power on that. I actually connected it back to a couple of receptacles there, dedicated circuits, because going to pull some current. Figured why have to connect it to the same thing as everything else over here. So one moment. I'm going to unplug that UPS right now. Okay, utility power not available. You can see input power is 0 volts. Output is a nice 120, and the battery is 94%. And it's estimating 18 minutes of runtime. And I'm plugging it back in. And let me turn that off. And I just tested the other UPS as well. That ran fine for a couple minutes on battery with this attached. I think we're good. Oh, I'd forget my head if it wasn't attached. One more thing. Look at this battery in particular. This is the only one that had a little bit of leakage and corrosion around the terminal, but you could see it was pretty bad. And this is the connector that was on that terminal. And as you can see, it's no longer a connector for anything. I chopped it right off and replaced it with a new one. And the reason I wanted to point this out, and it's kind of important, is that that connector is going to be just as corroded on the inside as this terminal is on the outside. And you can kind of see it right there, how it's like white and chalky on the inside. Now, in theory, you could get something that would fit in there that would give it a good scraping. I don't know, like a very fine metal bristle brush or some crap like that. In my opinion, if you have a battery connector that looks like this, that has corrosion on it, that looks all jacked up, just cut it off and replace it. Crimp on a new one like I did here. Fortunately, the wire was long enough that it would reach without this. But yeah, it's always a risk, because if you don't really get that as clean as you thought you did, then that corrosion slash electrolyte slash whatever is in there is going to create a high resistance connection, which means that as soon as you put this under load and you're running some, few amps through it, this interface, well, let's say you put it on a nice new clean terminal on a fresh battery, this is going to heat up, potentially heat up quite a bit, and that's going to heat up this terminal, which is going to heat up the electrode in this battery, which runs the risk of all sorts of things. I mean, in theory, if it got high enough, it could boil the electrolyte in here, which might make the sealed lead acid battery not quite so sealed. Could also start a little fire inside the UPS. I mean, I don't want to be alarmist. You know, these are sealed lead acid batteries. They're not known for bursting into flames, as I said before. But, you know, it could start a structure fire or something worse. The only reason I say probably not is because it's encased in pretty thick steel in the first place, and you'll probably notice some smoke and smell coming off of it. But anyway, point is, just beware of these kind of like corroded, potentially high resistance connections, because those can really do you in. All right, I think that's all I had to say. That's the last thing of note in this entire project. I say project, I mean, it's just UPS maintenance. It's something you should be doing. I should be doing more frequently, but I didn't, and there you go. That's why there was so much friggin' dust in there. Yeah, as I was saying, thanks for watching. Please consider liking and or subscribing to the channel and other YouTube-y outro type stuff. Goodbye. I forgot to slate the fucking thing again. How do I keep forgetting to slate? And I guess if you want to see them installed and operating, here they are on the shelf. It's nothing fancy. They ran out of room in the rack for like UPSs, so they just kind of sit here in tower configuration next to the APC. And like I said, these three UPSs are working in tandem. They're going to be sharing similar loads across automatic transfer switches. And yeah, looking pretty good. Like I said, not putting the bezels back on. And they're all labeled up with IP addresses and stuff. This should all be racked. I really just need to get another rack down here, I suppose. But, hey, is what it is. Should be fine. Alright, I'm done for real this time. Bye.